All right, so what we have here is a normal distribution. And so we want to draw that out because it's always nice to know what we're dealing with. And we have that mean in the middle. It is 100. We're also given the population size here, or the sample size, I'm sorry, which is 36. And the standard deviation, 24. All right, now what we're looking for is the middle 80%. So if we were to figure out two limits here, 80% of observations would be between those limits. So if we know this whole thing is 80, and we're going to need to use our table 3, table 3 only deals with the area from the middle to some point. So how big is this area then that we can actually look up in the table? Well, by symmetry, it's going to be an area of 40% or 0.4. So what we need to figure out is, first of all, what's this z value here? So we're going to use the table to find that z value. And then after that, we're going to use the formula for z. And then we're going to plug in our z. We know mu. We know the standard deviation, so we can solve for x. So how do we find this z? Well, we go to our table and we look for an area under the curve of 0.4. So the area under the curve, that's what's given in this part of the table here. So we're going to find a 0.4 and we're going to read off then later on in the margins what z value that is. I have conveniently underlined it here so I could find it. It is going to be, this number here is the closest, 0.3997. That corresponds to a z value of, if we go to the margin, we have a 1.2, and the second decimal up above of an 8. So it's 1.28. So 1.28. So then we know from this formula, z is 1.28 equals x, which we don't know what that actual x value is in terms of if the mean is 100 here. And we put in our mean, which is 100, standard deviation is 24, and then we multiply and add, etc., to get that x value, and that's going to give us this upper limit. And then however far away that is, we're going to go the same distance to the bottom to figure out the bottom limit. So that is basically how we do it.